An active region on the surface of the sun can be seen here releasing a solar flare. The image comes from NASA's Solar Dynamics Observatory. Credit NASAS. Paul Sutter is an astrophysicist at The Ohio State University and the chief scientist at COSI Science Center. Sutter leads science-themed tours around the world at astrotouring.com. Here it comes tomorrow, August 21st. A total solar eclipse will cross the United States from Oregon to South Carolina. Although everyone in the U.S. will get to enjoy at least a partial eclipse assuming there are no clouds blocking the sun, anyone within the roughly 70-mile-wide 113-kilometer strip of totality will get to see an unusual sight as the moon completely covers the sun. The mid-afternoon sky will plunge into darkness, and the moon itself will be encased in a dancing ring of fire, the solar corona, the thin but tremendous atmosphere of the sun. That corona is intimately tied to the sun's agitation level. You see, despite its placid appearance in our sky, an unfailing source of warmth and light, the sun is actually a roiling, boiling, frenzied inferno of extreme forces and energies. What you'll see during the 2017 total solar eclipse, I'm not just using the word boiling as a creative metaphor. The sun is literally boiling. The sun is hot on the inside, the nuclear fusion core, and relatively cold on the outside where it meets the vacuum of space. To transfer all the heat from the inside to the outside, the sun convects, meaning plumes of material near the core heat up, expand, and buoyantly rise to the surface, where they cool, condense, and slink back down to the depths. Sitting atop this boiling cauldron are the sunspots, gaping wounds in the sun where invisible twisted ropes of magnetic fields puncture the surface. Occasionally, these magnetic fields overtangle to the point of breaking, releasing tremendous amounts of energy in furious outbursts. That energy rips plasma material straight out of the sun itself. Its very guts get hurled into space. Most of the time, these prominences die back down, settling back onto the surface with no one the wiser. Hot plasma and light can be seen erupting from the surface of the sun in this video taken by NASA's Solar Terrestrial Relations Observatory on July 23, 2017. Credit NASA's Goddard Space Flight Center stereo Bill Thompson. But with sufficient energy, the material can completely separate from the sun and fling across the solar system. A massive ball of charged particles, with their attendant scrambled electric-magnetic fields, get ready to sweep over unsuspecting targets. So-called coronal mass ejections are usually harmless, because space is big and the Earth is small relatively. However, sometimes, these horror balls cross our path and really mess up our afternoon plans. When they do, satellites are forced to go into low-power safe mode, as the ensuing electromagnetic storm is hard on delicate circuits, and astronauts have to avoid spacewalks. On Earth's surface, we're protected by the planet's magnetic field, which funnels the charged particles into Earth's poles, giving us spectacular aurora light shows. But even then, those aren't the strongest possible storms. Severe ones can penetrate Earth's defensive force field, damaging our everyday electronics. Thankfully, we haven't had a powerful blast like that since the mid-1800s. And double thankfully, NASA has a network of satellites and telescopes, like the Solar Dynamics Observatory, that keep a careful eye on the sun and forecast the solar weather in our neck of the woods. Editor's note: visit space.com for a live solar eclipse webcast Monday, courtesy of NASA, beginning at 12 p.m. EDT 1600 GMT. Follow Paul at PaulMitsutter and Facebook.com PaulMitsutter. Follow us at space.com, Facebook and Google. Original article on space.com.